Hello students, myself Miss Akanksha Sangde Gurule. I again welcome you all in our physical chemistry class. So our fifth lecture is also based on numerical on enthalpy of neutralization. So in this I have discussed four numericals. So you have to first of all see them all. You have to practice them, and whatever the calculation that I have done that are done on the calculator. So calculator is allowed in your exam. Okay. So now we will start with our numerical. So our first numerical is determine the amount of heat released when 0.75 moles of nitric acid is neutralized by 0.75 mole of sodium hydroxide. So first of all, in this given question, there are many sub-questions. So one by one we will solve them. First we will write the reaction. What is given? The neutralization reaction between nitric acid and sodium hydroxide. So nitric acid, that means HNO3 plus sodium hydroxide, that is NaOH, reacts with each other to form NaNO3 plus H2O. Okay. Another thing, what is given? There is 0.75 moles of nitric acid and 0.75 moles of sodium hydroxide. Okay. So now, what you have to find? You have to find the heat released during this neutralization reaction. So, to calculate the heat released in neutralization reaction, there is one sentence that we have seen in the previous lecture, that is, when 1 mole of strong acid is neutralized by 1 mole of strong base and vice versa. Heat released is always equal to 57.1 kilojoule per mole. Is it okay? So here, when 1 mole acid is neutralized by the base, heat released is always equal to 57.1 kilojoule per mole. So now there is only 0.75 moles of HNO3 and 0.75 moles of NaOH. Now for 0.75 mole heat released is equal to 57.1 into 0.75, and which is equal to 42.8 kilojoule per mole. Okay. So in this, what you have to remember? You have to remember this term, that when 1 mole of strong acid is neutralized by the 1 mole of strong base or vice versa, heat release is always equal to 57.1 kilojoule per mole, and by comparing it with the given mole you can find the heat release for the given reaction. So our next sub question is, determine the amount of heat released when 0.75 mole of hydrochloric acid is neutralized by 0.5 mole of potassium hydroxide. First of all, we will write the given chemical reaction. That is, HCl reacts with KOH to give KCl plus H2O. Okay. Next, what is the given? There is 0.75 moles of HCl and 0.5 mole of KOH. So we have learned in the previous lecture that when 1 mole of strong acid is neutralized by 1 mole of strong base or vice versa, heat released is always equal to 57.1 kilojoule. Okay. So from here we can understand that there is only 0.5 mole of KOH and 0.75 moles of HCl. So there is a less amount of base. So that much base only will neutralize the acid. That means 0.5 mole of acid. Okay. So here for 1 mole heat released is equal to 57.1 kilojoule. For 0.5 mole heat released will be equal to 57.1 into 0.5, and which is equal to 28.5 kilojoule. Okay. Our next sub question is, when 900 ml of 0.5 molar hydrochloric acid solution is mixed with 500 ml of 0.4 molar sodium hydroxide, assuming the specific heat of water as 4.18 joule per Kelvin per gram, also calculate the rise in temperature. So in this, what we have to do? We have to find heat released. We have to find heat released and rise in temperature. Okay. So how you will find it? So we will go slowly. First, what we have to do? We have to calculate number of moles. Okay. And how you will calculate it? So always remember that 1000 ml 1 molar is equivalent to 1 mole. Okay. So for HCl, okay, for HCl, how many is there? 900 ml and molarity is 0.5 molar, and it will be equivalent to what now? Now we will do the cross multiplication, that is 1 into 900 into 0.5, okay, upon this 1000 into 1, and that comes 0.45 mole. So this is for HCl. Okay. So now we will calculate for NaOH. So for NaOH, again we will write 1000 ml, 1 molar is equivalent to 1 mole. Okay. So how much quantity is given to us? It is 500 ml and 0.4 molar. So it will be equal to 1 into 500 into 0.4 upon 1000 into 1. Okay, and it comes 0.2 mole. Okay, now we have known the number of moles of given solution. Now we will start with our next part. Now what we have known? Number of moles of HCl is equal to 0.45 mole. Okay. Next, number of moles of NaOH, that is 0.2 mole. So first we will find the heat released. So first we will write the reaction, that is HCl reacts with NaOH to form NaCl plus H2O. Okay. So now we will write the number of moles. That is HCl is 0.45 moles and NaOH is 0.2 moles. So okay. So here 0.2 moles of NaOH will react with 0.2 moles of HCl and 0.25 moles will be unreacted. So now when 1 mole of strong acid is neutralized by the 1 mole of strong base, heat released is equal to 57.1 kilojoule. Okay. For 0.2 mole, heat release is equal to 57.1 into 0.2. Okay, and that comes to be 11.4 kilojoule. Is it okay? Now what are the things that are known to us? Now we know the number of moles of HCl, that is 0.45 moles. Number of moles of NaOH, that is 0.2 mole. And now we know the heat released for the given reaction. So now we will calculate the rise in temperature. So what is the formula for that to calculate the rise in temperature? There is one important relation, that is mass into specific heat into rise in temperature is equal to heat evolved. Okay. So now we know the specific heat is given to us. Rise in temperature that we have to calculate. Heat released or heat evolved is also known to us. Now there is a question of mass. Okay. To calculate this mass, you have to remember that density is equal to mass upon volume. Okay. Here, assuming that density is equal to 1. Okay. So now mass is equal to density into volume. Is it clear? So if density is 1, then the mass will be equal to volume. So now mass of HCl is equal to volume of HCl, which is equal to 900 ml. Okay, so mass of HCl is equal to 900 gram. Similarly, mass of NaOH is equal to 500 gram, and overall mass of the reactant or the reacting species is equal to 900 plus 500, which is equal to 1400 gram. Okay, so now rise in temperature is equal to heat evolve upon mass into specific heat. Okay. Now substituting the values, that is 11.4 kilojoule, okay, upon mass is equal to 1400 grams into specific heat is given to us in a question, that is 4.18 joule per Kelvin per gram. Okay, so whenever you are solving any numerical, what you have to remember? You have to remember that the unit must be equal. So here there is a joule and here there is a kilojoule. So either you convert kilojoule to joule or joule to kilojoule. So what we will do? We will convert the kilojoule to joule, that is 11.4 into 10 raised to 3 joule upon 1400 gram into 4.18 joule per Kelvin per gram. Okay, so now we will cancel the same units, that means joule get cancelled with this joule, per gram cancels with gram, so only remaining is a per Kelvin. When this per Kelvin will transfer to the upside, that is in the numerator, it will be in the Kelvin, and when you will do this calculation, and it comes to be 1.94 Kelvin. So rise in temperature is equal to 1.94 Kelvin. Our next and the last question is 200 ml of 0.2 molar sulfuric acid is mixed with 300 ml of 0.1 molar sodium hydroxide solution. Calculate the rise in temperature. Given that specific heat is equal to 4.18 joule per Kelvin per gram. So similar question is there. Here we have to find the heat released and the rise in temperature. So we will go slowly, step by step. So now we will calculate the number of moles. We have seen this relation in the previous example, that is 1000 ml, 1 molar is equivalent to 1 mole. Okay. For H2SO4, the given is 200 ml, 0.2 molar. Now what we will do? we will cross multiply it. 1 into 200 into 0.2 upon 1000 into 1, and that is equal to 0.08 moles. Okay, now for NaOH. It is given that 300 ml, 0.1 molar. We will again cross multiply it. 1 into 300 into 0.1 upon 1000 into 1, and that comes to be 0.03. Okay, now we know the number of moles of NaOH and H2SO4. So next, what we have to see, that NaOH is in less quantity. That means 0.03 moles of NaOH will react with 0.03 moles of H2SO4, and the remaining 0.05 moles will be unreacted. Now, for 1 mole, heat release is equal to 57.1 kilojoule. Is it okay? For 0.03 mole, heat release will be equal to 57.1 into 0.03, and it will be equal to 1.7 kilojoule. That means heat release will be equal to 1.7 kilojoule. Okay, now what we have got? We have got heat release, number of moles of H2SO4 and NaOH. In the previous example, we have seen that rise in temperature is equal to heat evol upon mass into specific heat. Yes or no? Again, mass is equal to volume. That means mass is equal to 200 plus 300, which is equal to 500 gram. This explanation I have given you in the previous question. Okay, that we have to assuming D or density as unity. Okay, so now rise in temperature is equal to heat evol is 1.7 into 10 raised to 3. Why 10 raised to 3? We have converted kilojoule to joule. Mass is 500 gram into specific heat is given as 4.18 joule per Kelvin per gram, and that comes to be 0.8 Kelvin. Okay, rise in temperature. I hope that whatever the questions that we have taken here, that you have understood. So you have to practice them all at home. You have to prepare one notebook, solve each and every question in that and practice them. Okay? Thank you.